So the first one that I want to go over is actually 2 and 3 from the front page, and I'm just going to draw this graph that we had here. All right, and so this is the graph of f of x. So what number 2 said is, where is the slope of the tangent? And that means the derivative. So where is the derivative positive? So the derivative would be positive wherever this graph is increasing. So this graph is increasing during this section. So that would be negative infinity to 0. And then also increasing from 2 to infinity. And then number 3 said, where is the derivative negative? And the derivative would be negative where this graph is decreasing. So that would be from 0 to 2. So this is where the derivative is positive, and this is where the derivative is negative. And it's where f of x is increasing or decreasing. What happened a lot is people wrote both these answers for number 2 and then wrote something totally different for number 3. I think that was just a direction following issue. So just make sure that you read carefully, because it read like you knew what you were talking about, but kind of just didn't read the problem real carefully. So just be careful is all I'm saying there. And then the other one I want to make sure we go over is number 9. So this is the function that was given for number 9. So it is a piecewise function, and letter A was asking if the function was continuous. So that just means, do the two pieces meet up? So this side is just 4. For this side, if we plug in 2, 2 squared is going to be 4. So both pieces match up at the point 2, 4. And so the answer is yes, the function is continuous. The two pieces meet up. Letter B is asking about differentiability. And when I went over the test, I said, you're going to have to write something involving a limit there. We need the slopes from each side. So I need the slope from this side and the slope from this side. Now this slope I can get without having to do a limit. This is a constant function. It is just a flat line at 4. So the slope of that would be 0. And the common mistake I got on this one is people said that slope was 4. So I want to make sure we understand the difference. This is a constant function, just a flat line at 4. So that slope would be 0. If it was 4x, like I had a variable here, then that slope would be 4. But slope from the left side is 0. Slope from the right side, we're going to have to do a limit. And this part went okay. Writing out this limit, this like technically the quote unquote harder part of the problem, this part actually went all right. So its limit is x goes to 2, and then it's the function, which is x squared, minus whatever you get when you plug in 2, which when we plug in 2, 2 squared is 4. And then it would be over x minus 2. And so we're going to need to factor that. The numerator is going to split x plus 2, x minus 2. And so the x minus 2's are going to cancel. And when I plug in 2 to what's left, 2 plus 2 gives me 4. So the slope from this side is 4. And so the slope on the left was 0, slope on the right was 4. And so your answer to the whole thing is no, it's not differentiable because those slopes don't meet up. This would be a flat line, and then this would be a parabola. So they would meet at a sharp edge. So those were the ones I wanted to make sure I went over. But I will now open it up to you guys. And we have a little bit of time for this. So go ahead and type in the chat. You can type it to me privately if you want any other ones that you want me to go over for you. All right, let's look at 17. So we're getting the derivative, which is the instantaneous rate of change at -2. So we're using the same formula that we did right here. So it's going to be limit as x goes to -2. Sorry, this glare is like really bad. Let me try and move this over. Limit as x goes to -2, and then it's the function, which is 2x squared minus 5. So that's the function. And then minus whatever you get when you plug in -2. So if we plug -2 into this function, that would be 4 times 2 would be 8, minus 5 would be 3. So 3 is going to go there. So it's the function minus whatever we got when we plugged in -2. And then it's x minus -2. So that'll be x plus 2 in the denominator. So we're going to combine the like terms there. That'll be 2x squared minus 8. And then we're going to factor. So I'm going to factor out a 2. If I take out a 2, I'm going to be left with x squared minus 4. And x squared minus 4 is going to split x plus 2, x minus 2. And so these are going to cancel. And when you plug in -2, -2 minus 2 would be -4. And then -4 times 2 would give you -8. So your slope at -2 is -8. Or in other words, the derivative at -2 is -8. That is what we found there. Right, 18. A particular part of 18 or just all three of them? Or you are at B, I'm sorry. I did not look carefully, I'm sorry. Right, 18B. So this is the graph that you were given. And so graphing that derivative, we're gonna have a break at 1 because of that sharp edge. The slope for this part is -1. And the slope for this part is +1. So I'm going to have a flat line at -1 until I get to 1, because that's where this sharp edge is. And then I'm going to have a flat line at +1. I had to take off a little bit if you didn't stipulate that this was at 1. I had some people draw this but not like put any tick marks on their axes. I had to know that that was happening at 1. And there had to be open circles showing that there wasn't a point there. Right, and then 19, we have limit as x goes to 2 of this function. So if you plug in 2, you're going to get 0 over 0. That's indeterminate, and so that means that there is a hole, and we're going to need to factor. So the numerator will be x plus 2, x minus 2. And the denominator is going to split x minus 2, x plus 1. So the x minus 2's are going to cancel, and then you can plug 2 in for x. So numerator 2 plus 2 is 4, denominator 2 plus 1 is 3. All right, and then do you guys maybe want to pick one more? Or do you want me to do 20 since we're there anyway? Because I just did 19, we can do 20. Yeah, and then I got asked for 15. I'll go back to 15. I just figured no one said anything right away, so I was like, oh, I'll just do this one. So if you plug in -3 to this, in the numerator, -3 plus 1 will give you -2. And in the denominator, -3 plus 3 will be 0. So when you get indeterminate, 0 over 0, that means that there's a hole. This means that there's an asymptote. And so I just need to check whether the graph's going up or down. So this says -3 from the left I'm going to try and plug in -4 to the denominator. So if I put in -4 there, I'm going to get a negative result. And so I have a negative over a negative, which will be positive infinity. All right, and then let me just go back to 15 real quick. You know what, I'm not going to try to draw this graph. I'm just going to pull my answer key up here. So this is the graph that we had, and it's asking, or I just talk about 14 and 15. So this is, where is the function discontinuous? The only place we have a discontinuity is at 6. That's the only place that there was a jump. And then all the places the function is not differentiable. So 0 because of the sharp edge, and 4 because of the sharp edge, and 6 because of the discontinuity, and then 7 because of the vertical tangent line. And it said that one in the directions too, that there was a vertical tangent line at 7. So those were all the places where that function was not differentiable. All right, I'm gonna